All right, starting off 3.2, example 1, it's asking us, does the graph represent a linear or nonlinear function? Explain. All right, don't get confused by this word function. It's the same thing as equation. All right, now the first graph that we're looking at here, it's not a line. So this would be a nonlinear equation or function. All right, here we have a line. So this would be a linear function. All right, pretty simple stuff. Not much brain power there needed. All right, going on to the next example. Does the table represent a linear or nonlinear function? Okay, so this is how you determine if it's linear. There has to be a consistent difference between all the values used. Okay, if that's the case, then it's a linear function. All right, so essentially these are all points on the graph. All right, and they're going in ascending order, meaning we're moving up continuously. And as we do, all right, the same rate of change takes place for the x's. We're adding 3 on each time. And then the same rate of change takes place for the y. We're adding 6 on each time. And if that's the case, then you're going to get a line when you graph it. So it's a linear function. For the next one, however, let's see what happens here. Here I'm adding on 2, add on 2, add on 2. And then what happens with the y's? Add on 7, add on 11, add on 15. All right, now there's a consistent rate of change between the x values, adding on 2 each time. But for the y's, it's not consistent. So if it's ever not consistent, that means you're going to end up with a non-linear function. Okay? All right, on to the next example. Identify linear functions using equations. Okay, which of the following equations represents linear functions? All right, well, in order for it to be a linear function, it has to have this structure, y equals mx plus b. All right, let's see which ones have this structure. This one does not. It has a square root in there. If it has a square root, it can't be a linear function. This one has an exponent. All right, if it has an exponent, it can't be a linear function. This one has x on the bottom. All right, x is supposed to be on the top, so that can't be a linear function. And let's see, what do we have here? Maybe, we'll work with that in a second. Here we have x squared. Once again, we have a exponent greater than 1, so that can't be a linear function. All right, so it's in between these two here. All right, now why is y equals 3.8 a linear function? Well, can you rewrite it so it has that structure? Sure you can. Y equals, well, what happened to the x? M must have been 0. All right, so you could rewrite this as that, and it does have a linear structure. So y equals 3.8 is one of your answers. And then for the next one, what's going on with this here? All right, well, I'm going to distribute the 6. Let's see what happens. All right, so now I just converted this here to this, and look at the structure of it. Same as above, y equals mx plus b. So it has a linear structure. So this is also one of our answers. All right, and that's all you're doing in this lesson. All right, just identifying linear functions or linear equations. All right, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.